بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. This is section 3.11 about hyperbolic functions. Well, hyperbolic functions are defined as combinations of the exponential functions e to the power x and e to the power negative x. They are analogous to the trigonometric functions. They have the same relationship to the hyperbola like the trigonometric functions have to the circle. So for example, the equation of the unit circle is x squared plus y squared equals 1. And in the unit circle, x is cosine t and y is sine t. So the famous identity in the trigonometric functions is sine squared plus cosine squared equals 1. This comes from the unit circle. Now in the hyperbola has the equation x squared minus y squared equals 1. And x is hyperbolic sine, hyperbolic cosine, and y is hyperbolic sine. So we have a relation cosh square x minus sinh square x equals 1, because x squared minus y squared is 1. Hyperbolic functions are related to the hyperbola x squared minus y squared equals 1, and the trigonometric functions similar to the trigonometric functions that are related to the circle. So for that reason, we call them hyperbolic sine, hyperbolic cosine, because of the symmetry between these two types of functions. Now these are the definitions. Hyperbolic sine, or I'll call it just sinh x, is e to the power x minus e to the power negative x over 2. While hyperbolic cosine, or I will call it cosh x, is e to the power x plus e to the power negative x over 2. So sinh negative, cosh positive. And both of them, in both of these two functions, we are finding a combination between half of ex and half of e negative x. So when we subtract, we get the sinh. So this is the graph of half ex, you know, the graph of the exponential function. And if you multiply by negative, the same graph reflected about the x-axis would be the green one. And if you add these two, half ex and negative half ex, for example, this is here, this point is at 0, we will have half, and here at 0, negative half. If you add half and negative half, you get 0. So the red curve, the curve in red would be the graph of sinh x. Notice that the graph of sinh x has the domain from negative infinity to infinity, or real numbers. And also the range of this function is all real numbers from negative infinity to infinity. So this is the graph of sinh x, and this is the definition. It is half ex minus half e negative x, or you can say, if you when you add these two, ex minus e to the power negative x over 2. Cosh will be the addition of these two. And if you add the blue and the green, you will get this red curve now. Because, for example, this is half in the red, half in the green. If you add half plus half, you get 1. So cosh 0 is 1. This is the graph of cosh x, and you can also see that the domain and the range would be all real numbers. Now, for the other functions, the definitions are similar to the trigonometric functions. So for example, what is the reciprocal of sine in the trigonometric functions? It is cosecant. So here the reciprocal of hyperbolic sine is hyperbolic cosecant, and the reciprocal of hyperbolic cosine is hyperbolic secant. And the hyperbolic tan would be the hyperbolic sine over the hyperbolic cosine, similar to the trigonometric function tan x, which is equal to sine x over cosine x. And the hyperbolic cotan would be 1 over the hyperbolic tan, or just hyperbolic cosine or cosh over sinh. So these are easy for you to remember, I believe, but these two definitions, you need to pay attention to them to remember always the definition of the hyperbolic functions. For the graph of the hyperbolic tan, this would be the graph of the hyperbolic tan. Okay. Also, the definition of the hyperbolic tan, when you divide sinh over cosh, okay, you can cancel 2 with 2, and the hyperbolic tan would be equal to e to the power x minus e to the power negative x over e to the power x plus e to the power negative x. So you can say that this is the definition of the hyperbolic tan. Of course, it's also equal to sinh over cosh. It has two horizontal asymptotes, y equals 1 and y equals negative 1. The domain is all real numbers, while the range is from negative 1 to 1. Hyperbolic tan of 0 is 0. Okay, so this is the graph. Of course, if you replace x by 0 here, you get e to the power 0, which is 1, minus e to the power 0, which is 1. 1 minus 1 would be 0 over 2, that's 0. So hyperbolic tan of 0 is 0, as you can see. Okay, let us have some questions. Write 8 sinh x plus 5 cosh x in terms of ex and e to the power negative x. Well, 8 sinh x plus 5 cosh x would be 8 times. Sinh by definition e to the power x minus e to the power negative x over 2. And cosh by definition is e to the power x plus e to the power negative x over 2. 8 over 2 is 4. Or let me keep the 2 without dividing 8 over 2. Let me multiply. So I have 8 times ex minus 8 times e negative x. I'm multiplying because I have the same denominator, so I can just write both fractions over 2, and I multiply here 5ex plus 5e negative x. So the answer would be 8ex plus 5ex is 13ex, and negative 8 plus 5 is negative 3 e to the power negative x over 2. So this would be the answer. Okay, if you want to write it 13 over 2 ex minus 3 over 2 e negative x, that's also similar. Now another question, write this in terms of sinh to x and cosh to x. Well, here I have to write the definition of sinh to x first. Well, sinh to x would be e to the power 2x minus e to the power negative 2x over 2. So you replace x by 2x in the definition of sinh. Also, cosh tx would be e to the power 2x plus e to the power negative 2x over 2. So to write these two terms in terms of sinh and cosh, I will say 2e 2x plus 3e to the power negative 2x, which is this one, equals to, it would be, if it would be a combination, okay, of sinh and cosh. So it would be a, let us say a times sinh 2x plus b times cosh 2x. and I need to solve this equation and find the values of A and B. Then I will be able to write this in terms of sinh and cosh. Now, if I add these two also, I have the same 2 here. So I will write it 2. I will add these two fractions. So I will have A. Notice that I have here e to x and e to x here. So if I take e to the power 2x as a common factor, I will have A plus B times e to the power 2x, and then plus. For e to the power negative 2x, the coefficient in the first term is negative a, and the coefficient of the second term is b. Okay, so I can write these two terms like this. Now I can say that comparing this side to this side, the coefficient of e to the power 2x should be the same in both sides. So the coefficient of e to the power 2x here is 2, and the coefficient of e to the power x here is a plus b over 2. The coefficient of e to the power negative 2x in the left-hand side is 3, and the coefficient of e to the power negative 2x in the left-hand side, in the right-hand side, is negative a plus b over 2. So by this, I have two equations, and I can solve them and find the values of a and b. So in the first equation, if I multiply by 2, I will have a plus b equals 4. The second equation, I will have negative a plus b equals to 6. Now, if I add these two equations, 2b would be 10, which means that b is 5. And if b is 5, then a plus 5 is 4, and then a is 4 minus 5, or negative 1. So in fact, 2e to the power 2x plus 3e to the power negative 2x would be equal to a times sinh 2x, and a is negative 1, so it is negative sinh 2x, plus b times cosh 2x, and b is 5, so plus 5 cosh 2x. So if you multiply sinh 2x by negative 1, add it with 5 times cosh 2x, you will find the answer 2e to the power 2x plus 3e to the power negative 2x. So this exercise is the converse of this exercise. Okay, he will give you something like this, and then you need to write it back as 8 sinh plus cosh x or something else. And the way to solve it is this way, this method. Of course, you can solve this equation, the first equation, by different ways. You can multiply by 2 to get rid of the denominator first, okay? But at the end, the idea is the same. You need to compare the coefficients of e to the power 2x in the two sides and the coefficients of e to the power negative 2x in the two sides to solve the two equations and find the values of a and b. Write sinh ln x as a rational function of x. Well, the definition of sinh x is e to the power x minus e to the power negative x over 2. So I will replace x by ln x. So that's the definition of sinh ln x. Now e cancels ln, and I have x here. But here notice that e cannot cancel ln because I have a minus sign outside. But I can take this minus side here, this minus sign up here, using the properties of the logarithmic function. And now e cancels n, and I have x to the power negative 1 over 2. That's the answer, but to write it as a rational function, I need to write this as a polynomial. The numerator should be a polynomial, and if it has a power of negative 1, then it is not a polynomial. I can write it half, okay, times x minus x to the power negative 1. I can write it 1 over x. And I can add these two fractions now. So here I have 1. So use the formula to add these two rational functions. So I have x, and here I have x times x minus 1. So the final answer would be x squared minus 1 over 2x. And this is a rational function, and that's the answer. Write cosh for ln x as a rational function. Similar to the previous question. The only difference that here we have cosh, and instead of x now I will write 4 ln x, and I have here plus because cosh, and here I'll have negative 4 ln x over 2. I cannot here cancel e with len because there is a 4, there is a coefficient. So I use the properties of len to take the 4 up. Here also I will take the negative 4 up. And now I can cancel e with len, and I will take half outside. So I'll have here x to the power 4 plus x to the power negative 4, which I can write it 1 over x to the power 4. So I write it as a rational function. When you add these two fractions, you get x to the power 4 times 1. And here x to the power 4 times x to the power 4 is x to the power 8. You add the powers plus 1. So the final answer would be x to the power 8 plus 1 over 2 times x to the power 4. Let us use here the definition of the hyperbolic functions to find these limits. Well, the limit, the hyperbolic tan, we said that the definition I wrote it as it is sinh over cosh, so it's e to the power x minus e to the power negative x over e to the power x plus e to the power negative x, and the 2 cancels with the 2, so this is the hyperbolic tan. Now if you replace x by infinity, you will get e to the power infinity, and notice that the graph of e is like this. So limit ex when x goes to infinity is infinity. So I can say e to the power infinity is infinity, while the limit when x approaches negative infinity of ex is 0 because the function goes to 0. The line y equals to 0 is a horizontal asymptote. So I can say that e to the power negative infinity is 0. So here I'll have infinity minus 0 over infinity plus 0, so infinity over infinity. Once I have infinity over infinity, I have to do something to find the limit. So usually, if you remember, we divide by the highest power. So you can divide by e to the power x here, okay? Or you can multiply by e to the power negative x. E to the power negative x is 1 over e to the power x. So you are dividing actually by e to the power x. So let us multiply by e to the power negative e to the power x times e to the power negative x is e to the power 0, which is 1. And here e to the power negative x times e to the power negative x, you will add the powers, and you will have e to the power negative 2x. And now if you replace x by infinity, e to the power negative infinity is 0. So you will have 1 minus 0 over 1 plus 0, and the answer is 1. So the limit is 1. It is the same here, but x approaches negative infinity. And when x approaches negative infinity, e to the power negative infinity would be 0. So here you will have 0 minus infinity over 0 plus infinity. And here you need to divide by e to the power negative x, not e to the power x. So I will multiply by e to the power x over e to the power x. It is similar as dividing numerator and denominator by e to the power negative x. So I will have e to the power x times e to the power x, e to the power 2x, and e to the power negative x times e to the power x is e to the power 0, which is 1. And here e to the power 2x plus 1. And now if you replace x by negative infinity, e to the power negative infinity would be 0 minus 1, 0 plus 1. So the answer is 1. For sinh, the definition of sinh is e to the power x minus e to the power negative x over 2. Now, if I replace x by infinity, I'll have e to the power infinity, which is infinity. E to the power negative infinity is 0 over 2. Infinity minus 0 is infinity. Infinity over 2 is infinity. So the limit is infinity. The same sinh, but when x goes to negative infinity. You need to write the definition of sinh first. E to the power negative infinity is 0. Minus e to the power negative infinity is e to the power infinity, which is infinity. 0 minus infinity is negative infinity. Negative infinity over 2 is negative infinity, and the answer is negative infinity. Hyperbolic secant is the reciprocal of hyperbolic cosine or cosh. Cosh is e to the power x plus e to the power negative x over 2. So the hyperbolic secant would be the reciprocal. Now, if I replace x by infinity, e to the power infinity is infinity. E to the power negative infinity is 0. Infinity plus 0 is infinity. 2 over infinity is 0. So the limit is 0. And this means that for the graph of secant, as x approaches infinity, the graph approaches 0. So it's like this. Okay, the graph of secant, of hyperbolic secant, approaches 0. It could approach the 0 from above or from below. We need to choose points to check, but this is what we get from finding the limit when x approaches infinity. For the hyperbolic cotan, it is the reciprocal of tan. So tan is e to the power x minus e to the power negative x over e to the power x plus. So this would be the reciprocal. So plus up and negative down. Now if I replace x by infinity, I'll have infinity plus 0 over infinity plus 0. So, sorry, this is minus and this is a plus. So I need to multiply by e to the power negative x to get rid of the infinity, or yeah, divide by e to the power x. So the limit would be e to the power x times e to the power negative x is 1, and here e to the power negative 2x, and here 1, x plus minus x is 0, and negative e to the power negative 2x. And the limit would be 1 minus 0, 1 here plus 1 plus 0 over 1 minus 0, or just 1. So the limit is 1. Well, for hyperbolic cosecant is the reciprocal of hyperbolic sine. And hyperbolic sine is e to the power x minus e to the power negative x over 2. So hyperbolic cosecant would be the reciprocal. Now, e to the power negative infinity is 0, and e to the power negative infinity would be e to the power infinity, which is infinity. So this would be 2 over negative infinity, which is 0. So the limit is 0. So now I hope you understand the definition and you memorized it after solving all of these exercises about the definitions. Now there are some identities that we can find from the definitions. For example, sinh negative x is negative sinh x, and this means that sinh is an odd function because f of negative x is negative f of x, and this is the definition of the odd function. While cosh is an even function because f of negative x equals f of x. And if you remember the graphs, from the graphs you can figure out that sinh is odd and cosh is even. To prove these two, it's easy to do that. To prove, I can start by the left-hand side here, and let me write the definition of sinh negative x. It is e to the power x minus e to the power negative x over 2. But here I have negative x, So I will have negative x here and negative x here, so it will be positive x. Now, if you take negative sign as a common factor, then you will have ex minus e to the power negative x. And this e to the power x minus is just sinh x, and that's the right hand side. So remember, uh, to take a common factor, you are taking just the negative sign as a common factor. So e to the power negative x would have a negative coefficient, e to the power x would have a positive coefficient, and it's like this. Okay, whenever you have a minus b and you take a negative sign as a common factor, you will have negative a plus b, or you can write it b minus a. This is how to take negative as a common factor. Here, to prove that cosh is an even function, if we start by the left hand side, cosh negative x by definition is e to the power x plus e to the power negative x over 2. But I'm replacing x by negative x, so I'll have negative x here and x here. Well, this is exactly e to the power x plus e to the power negative x over 2, which is cosh x. So the proof is easy because 5 plus 4 is just 4 plus 5. Okay. Some more identities. This is the famous identity cosh square minus sinh square equals to 1, which came from the hyperbola x square minus y square is 1. And to prove it, to prove cosh square minus sinh square is 1, we can write the definition of cosh, which is e to the power x plus e to the power negative x over 2, and raise it to the power 2 minus, and we write the definition of sinh, which is e to the power x minus e to the power negative x over 2, and raise it to the power 2. Now, to raise these two terms to the power 2, I will write it over 4. Okay, 2 squared is 4. And here, e to the power x to the power 2 is e to the power 2x plus 2 times e to the power x times e to the power negative x plus e to the power negative x to the power 2 is e to the power negative 2x, and then minus. And notice that I have also here 4 as a denominator, so I can write both fractions with denominator 4, and I'll keep the minus outside and find the square of these two terms. E to the power x squared is e to the power 2x, and I have minus 2 e to the power x times e to the power negative x, and minus squared plus e to the power negative 2x. And now you can expand. Now this is e to the power x times e to the power negative x is 1, and expand the negative sign. So negative e to the power 2x, negative times negative is positive 2, and e to the power x times e to the power negative x is 1, and then I have negative e to the power negative 2x over 4. Can see that e to the power 2x cancels and e to the power negative 2x cancels, and I have 4 over 4, which is 1, and that's the right hand side. So this is the proof of part B. Sorry, A. Part B, you can find part B from part A if you just divide both sides in part A by cosh square x. So I'm writing part A as it is, the left-hand side of part A, and I'm dividing by cosh square. In the right-hand side, I have 1, and I will divide the 1 over cosh square. And now cosh over cosh square over cosh square is just 1. And sinh over cosh is tanh, or hyperbolic tan. And 1 over cosh is hyperbolic secant. And this is the identity in B. So we prove B easily when we divide the two sides of A by cosh square. Also, if you divide the two sides of A by sinh square, you will get cosh over sinh, that's the hyperbolic tan, and sinh over sinh would be 1, and 1 over sinh would be the hyperbolic cosecant. So we will have also this relation between the hyperbolic cotan and the hyperbolic cosecant. Also, we have these two formulas, sinh x plus y and sinh cosh is x plus y, similar to the formulas we have in the trigonometric functions sine x plus y and cosine x plus y. But here we have positive in both formulas, so it's easier. To prove this, you can take the right-hand side and divide by a combination of sinh x cosh sinh x sinh y or something like this, and uh, to get to the definition of sinh x plus y, because sinh x plus y is ex plus y minus e to the power negative x negative y. So you can do it if you like. You can find it easily. It's a nice exercise for you. Prove the identities, still with some exercises about more identities. Usually you start by the left-hand side. It has more work here. And write the definition of cosh. It is ex plus e to the power negative x over 2. And write the definition of sinh. Okay, and try to add these two fractions and to try to get to the right-hand side. So I have e to the power x plus e to the power negative x. Negative times negative would be positive. I can add these two fractions easily. I hope you know this formula, because whenever you have a over b plus c over b, you can just add a plus c over b if you have the same denominator. So ex cancels with negative ex, and I'll have 2 uh, e to the power negative ex over 2, and you can cancel 2 with 2, and the answer would be e to the power negative x, which is actually the right hand side. So this is the proof. Another identity. I'll start also by the left-hand side. Write the definition of hyperbolic tan. You remember it is e to the power x, but here I have ln x, minus e to the power negative ln x over e to the power ln x plus e to the power negative ln x. Well, e cancels with ln. Here I can't, so I will take the negative sign up. Here cancels, here I can't, so I'll take the negative sign up. And now I can cancel, and I will have x minus x to the power negative 1 and x plus x to the power negative 1. If I multiply by x over x, I will get rid of the negative power. So I'll have x squared plus, minus x to the power negative 1 times x. I will have x to the power 0, which is 1, and x times x is x squared, and x times x to the power negative 1 is just 1, and this is actually the right-hand side. So all of these identities are easy. Just write the definition and simplify. Here again, the left-hand side, we start by it because we can work with it. Let me use here the definition of uh, sinh, or I can do it in any, let me do it like this. Sinh x over cosh x, okay, 1 minus sinh x over cosh x, because hyperbolic tan is sinh over cosh. Now I will multiply to get rid of the denominators. Let me multiply by cosh x over cosh x. Okay, so I will have cosh x plus sinh x over cosh x, and when I multiply here this by this, cosh cancels with cosh, and I have sinh x. And now I can write the definition. Definition of cosh is e to the power x plus e to the power negative x over 2, and here same with a minus sign, and here and now to get rid of the numerators, I can multiply by 2 over 2. So I will have e to the power x plus e to the power negative x plus e to the power x minus e to the power negative x over the 2 will be cancelled, and I'll have ex plus e negative x. And now notice that there is a minus sign, so it will be multiplied by ex and by e to the power negative x, and it will make it positive. And now this cancels with this, and this cancels with this. So I'll have 2 times e to the power x over 2 times e to the power negative x. 2 cancels with 2, and I'll have ex over e to the power negative x. You can add the powers, subtract the powers, or you can bring e to the power negative x up, so it would be e to the power x, and if you add them, you get e to the power 2x, and this is exactly the right hand side. Okay, now to the last part of this section, which is the derivative. How to find the derivatives of the hyperbolic functions. Well, you can prove easily that the derivative of sinh is cosh, and the derivative of cosh is sinh. Also, the derivative of hyperbolic tan is hyperbolic secant square. And this is similar to the trigonometric functions, but here we know that the derivative of cosine x is negative sign. Here it's positive. So it's easy dealing with hyperbolic functions because there is no negative sign. Hyperbolic tan is secant square, so this is also similar. Okay, but this is not similar to the trigonometric. There is a negative sign. And the derivative of hyperbolic cosecant is negative hyperbolic cosecant times hyperbolic cotan. This is similar to derivative of cosecant x in the trigonometric. Derivative of secant has no negative sign. So here, derivative of hyperbolic secant is negative hyperbolic secant. Derivative of hyperbolic cotan is similar to the derivative of cotan. So you can say that the difference here is in hyperbolic cosine and its reciprocal. They differ by the derivatives of the trigonometric functions with a minus sign, by a minus sign. Okay, but the others are similar in the signs. You can prove all of this easily. For example, to find the derivative of sinh x, actually sinh x is e to the power x minus e to the power negative x over 2. So to find the derivative, you keep the 2 because it's a number, and the derivative of e to the power x is e to the power x minus the derivative of e to the power negative x is e to the power negative x times negative 1. And this is in fact cosh x. So you can see easily that the derivative of sinh is cosh. And you can also find the derivative of cosh similarly. And the derivative of hyperbolic tan, you can use the quotient rule, sinh over cosh, or you can use the definition ex minus e to the power negative x over ex plus e to the power negative x. You can prove these formulas easily. Let us apply them. What is the derivative? Now you can use chain rule, product rule, quotient rule with the new formulas of derivatives of hyperbolic functions. So here we have chain rule to find dy by dx. We find the derivative of the outer function, which is cosh. Derivative of cosh is sinh. And then we multiply by the derivative of the square root of x, which is 1 over 2 square root of x. So I can just write it like this. And that's the answer. Also find the derivatives here. So f prime x is derivative of cosh is sinh, and derivative of 3x is 3. Here I use the product formula. Derivative of ex is ex times the second function plus the derivative ex as it is times the derivative of cosh, which is sinh. So this would be the answer. Here I have a composition. So I start by finding the derivative of the outer function. Derivative of sinh is cosh. And then I multiply by the derivative of x squared, which is 2x. And I will write it here. So this would be the derivative. Now remember, this is sinh to the power 2, or if you want, you can write it like this. Okay? It is exactly equal to this. So this helps you to remember that the derivative you start, this is a chain rule. You have to find the derivative of the power function first, the outer function, which is 2 times sinh x to the power 1, and then times the derivative of what is inside parentheses, which is sinh. The derivative of sinh is cosh x. So that's the derivative. Here also, I have a composition, so I use the chain rule. So g prime of t, derivative of sinh, the outer function, is cosh, times the derivative of len t, which is 1 over t. So I'll just write it like this. Here I have also a composition, and the derivative of ln, which is the outer function, is 1 over sinh t times the derivative of sinh, which is cosh t. I can leave it like this, or I can just write it hyperbolic cotan t. Here I have also composition. So using the chain rule, the derivative of e is e, that's the outer function, hyperbolic tan of 2v. Now times the derivative of hyperbolic tan, which is derivative of hyperbolic tan is hyperbolic secant square of 2v times the derivative of 2v, which is 2. I can write it here. Well, here I have product, so I will use the product formula. So derivative of hyperbolic secant is negative, remember? Hyperbolic secant times hyperbolic tan. This is the derivative of the first function, secant, hyperbolic secant. So times the second function, which is hyperbolic tan x plus secant, hyperbolic secant, I write it as it is. Then multiplying by the derivative of hyperbolic tan, which is hyperbolic secant square. So if you want, you can write it as negative hyperbolic secant times hyperbolic tan to the power 2. And here you have hyperbolic secant to the power 3 when you add the powers. Again, this is the chain rule. So the derivative of the outer function, derivative of hyperbolic secant, is hyperbolic secant with a negative sign times hyperbolic tan, and you keep the inner function as it is. So derivative of hyperbolic secant is negative hyperbolic secant times hyperbolic tan. Now times the derivative of hyperbolic tan, which is inside, which is hyperbolic secant square x. Okay, there is nothing I can do here, so I will leave them as they are. Here I have product function. So the derivative of derivative of t is 1 times the hyperbolic cotan of t square plus 1 plus t times. Now the derivative of hyperbolic cotan is hyperbolic cosecant square. Actually, negative hyperbolic cosecant square. So there is a negative sign, so I will write it here. But it is not x what is inside the hyperbolic cotan. It is a square root of t square plus 1. Then times the derivative of the square root of t square plus 1, which is 1 over 2 times the square root times the derivative of t square plus 1, which is 2t. So when I multiply by 2t in the numerator, this 2 would be cancelled, and t times 2 would be t square. So this would be the final answer. Now, here I will use the quotient rule. So 1 minus sinh t to the power 2. Derivative of the numerator, derivative of 1 is 0, derivative of sinh is cosh times the denominator minus the numerator times the derivative of the denominator, which is negative. The negative I will make this positive. Derivative of sinh is positive cosh t. So this negative sign comes from this negative. So now I can expand. So I'll have cosh t minus cosh t sinh t plus cosh t plus sinh t cosh t. These two will be cancelled, and the final answer would be 2 cosh t over 1 minus sinh t to the power 2. That's the end. I hope you understand now the hyperbolic functions and their identities.